Okay, now we're going to look at fractions and algebra within fractions. The first thing we want to look at is equivalent fractions. The first one is 3/4, and we want to get it to eighths. Now the denominator, the number on the bottom, is double. 4 has been doubled, or times 2 to get 8. So what you do to the bottom, you've got to do to the top. So if the bottom's times 2, then the top is times 2. 3 2s are 6. So 3/4 is the same as 6 on 8. The next one is over 40, 15 on 40. They've told us what the numerator has to be 45, and you can see that that is 3 times as big. So that means the bottom has to be 3 times as big. So that's 120, so it's 45 on 120. Sometimes questions say go back the other way, you need to cancel them. So for example, if you had 6 on 8, we have to make those numbers smaller, and you say what's a common factor to 6 and 8? And a common factor would be 2. 2 goes into both of those, so you divide the top by 2 and you get 3. You divide the bottom by 2 and you get 4. So that's going back the other way, ending up with the same answer. You do that here. If you're given 45 on 120, you say what number is common to top and bottom, and you'd say 3. So you divide the top by 3 and you get 15. Divide the bottom by 3 and you get 40, so end up with the same. But notice we can actually go further, because there's a common factor that goes into 15 and 40, and that's 5. So if you divide the top by 5, you'll get 3. If you divide the bottom by 5, you'd get 8. So that's equivalent to 3/8. That's called cancelling down. Next question is about improper fractions. If you've got 4 2/3, to convert that, you multiply the 4 and the 3 and get 12, and then you add 2 to get 14 all over the denominator. So that's 14 on 3. This is going back the other way. This is an improper fraction and we want to get it as a mixed number. So you say, what do we have to times 3 by to get 10? Well, 3 3s are 9, leaving a remainder of 1, so it's 3 1/3. That's how you convert between improper and mixed. Now we're going to get into adding fractions, timesing fractions, and dividing fractions. So the first one is adding. Now to add, we need to have a common denominator, and that's why we needed to do this up here as an introduction in getting common denominators. First thing, we have to look at the factors of multiples of these two numbers, and you can see 8 doesn't go into 12. The next thing that 8 would go into and 12 would go into would be 24. That's the lowest common multiple of these two numbers. So if we look at 12, to get that to 24, we're going to times that by 2. If we times the bottom by 2, we have to times the top by 2. And so that becomes 14 divided by 24. Now if we look at the other one, we have to get that to 24 as well, but have to times 8 by 3, and we have to times the 3 by 3. So that's plus 9 on 24. Now that we have the same denominator, you don't change the denominator, but you do add the tops. 14 plus 9 is 23. So that's our answer when we add those two fractions together. Okay, you can just pause the video and try B and C and come back for the solutions. Alright, next one's 9 on 20 and 2x on 5. So we've got x coming in. To get the lowest common multiple, we could get 5 goes into 20 4 times. So we could times the bottom by 4 and we could times the top by 4. We don't have to do anything to the fraction on the left. So that's 9 on 20 minus, the bottom one is 20, 5 fours are 20. The top 4 times 2x is 8x, 4 twos are 8. Now you keep the denominator the same, so it's all over 20. And we can't do 9 take 8x because they're different terms, so you just leave it like that. That's your final answer. Part C, we have 3x and 2 on the denominator. The lowest common multiple will be 6x. So we're going to times this by 2 on the bottom, times the top by 2. This one will times by 3x and the top by 3x. If we do that, we're going to get 6x on the bottom. So 6x on the bottom there, and up here 2 2s are 4. This one here is 6x, and up the top we have 15x. Now 6x, keep common denominator, is still 6x, and up the top we have 4 plus 15x. Okay, now we're going to do multiplication of fractions, and the first one is 5 on 11 times 7 on 2. These is quite simple. All we do is we multiply the tops and multiply the bottoms. So 7 5s are 35 and 11 2 22, and that's your final answer. Okay, you pause the video and try B and C. Now here's the answer for B. Notice it's 7 is not a fraction. We could actually say 7 is the same as 7 on 1, and then we do 7 2s are 14, and 1 times 9 is 9. Common error I see with timesing 7 is if the people don't put the 1 down, they times the 2 by the 7 and the 9 by the 7. So you can see here that the 7 only gets multiplied by the top number. The 9 stays 9 because you're really timesing by 1. The next one, 5 and 4 times 4x, the same thing. The 4x just gets multiplied by the 5 because that's really over 1. Notice there's no times here because it can get confused with the x. We just put in brackets. If there's nothing there, it's assumed to be times. 5 times 4x is 20x, and 4 times 1 is 4. Now you could cancel that down. 20, divide 20 by 4 and get 5, and divide 4 by 4 and get 1. So overall it's 5x. You could have jumped straight to that answer from the start. You could have gone right through to there, because you could have said, well, we'll cancel the 4s. You're really dividing top and bottom by 4 and end up with 5x. And the last type of fractions operation is divide. When you divide fractions, you invert multiply. So the last one, you've got to flip upside down and change the divide to a times. So it's 5 on 11 times by 2 on 7, and do the same as last time. Multiply tops and multiply bottoms. Okay, pause the video and try the next two. And part B, when we divide by 7, you could call that 7 on 1, so we're going to invert multiply. So it's 2 on 9 times by 1 on 7. So it's 2 on the top, 1 2s, and 7 9 63 on the bottom. Notice also that some people, instead of using divide, this is probably better at senior school, we say 2/9 and we're dividing it by 7. And actually the quick way, rather than doing all that, is the 7 gets multiplied into the bottom to give 63. So it's 2 on 63. The next one, 7 divide 5 on 11. We could have 7 on 1, and we're going to flip the second one and change divide into times, so it's 11 on 5, and 7 11s 77, and 1 times 5 is 5. Okay.